This is passage 5. I call this one a lab report. It's a little interesting because it's just one experiment, so it's kind of like data, it just has one data passage. But then it has the explanation of how the experiment was done. So it's a little bit like research. So I call it a lab report. And I say you approach it kind of like data, kind of like research. If you get to the end of the test and you're running short on time, skip the passage, skip reading it, and just look at the data and do those that refer to the data. But you're going to have some questions that refer to the reading and ask you about the procedures of the experiment. So as you're approaching these, I think the best way to answer the questions is the R&R approach. Read, then reread, do a quick read through of the question, then reread it and break it down. We're going to reread and break it down step by step as I go through the questions with you. Number 27, what is the order of PB, SB, and SN? So that's going to be here in the metals. From the substance with the smallest accepted CP to the substance with the greatest accepted CP. So that's here. We're just looking at those three metals. And smallest to largest, they actually follow suit. They decrease as they get on the chart. So PB, SB, SN, choice C. Number 28, how many protons are in an atom? So that's going to be the atomic number, a little bit of knowledge there. Of the metal that had an average experimental CP, so average experimental CP of 0.217. So that's that one. So the atomic number is 50, so your answer is H. Number 29, which of the metals tested in the experiment had the greatest absolute difference between the average experimental CP and the accepted CP? So that's the difference between those two. So we're going to subtract, and we're only looking at these four metals. So we can just those four. We don't have to do SN. We don't have to do 10. And so we're just going to check each one, subtracting. So the difference between average experimental and accepted for aluminum is 0.09. And for copper, it's 0.004 and 0.008, 0.002. So the greatest is aluminum, A. Number 30, based on the results of the experiment and the information in the passage, we're going to use both, did the greatest average temperature change in water? So we know that's here in step 5, temperature change in water. It also explains it in the experiment where they're averaging the temperature change in the water and the temperature change in the metal to come up with the specific heat. So we're going to look at aluminum, and we're going to look at lead, so Al and Pb. So now we're going to say, all right, well, the answers say we're going to talk about the greatest or smallest CP value. CP is the specific heat to raise the specific heat of the substance. So let's go ahead and say we know we can eliminate G and H. Even if you don't process the question well, you can say G is wrong because it is not the metal with the smallest CP. And H is wrong because it is not the metal with the greatest CP. So those two are out. Then you got to use a little bit of science reasoning to say the one that has the greatest CP value is the one that would most likely change the greatest water temperature. So it has to be F. Number 31, for the 5 metals tested, as the atomic number increased, and there's not a set pattern in that column, so we have to reorder them. Really annoying. So we'll just reorder them, write them down. The average experimental CP does what? So now we're going to match the experimental CP with the correct ones. And so when we do that, we can see as the atomic number increases, the average experimental CP decreased only. So B. Tricky question because it's just annoying to reorder. Number 32. Based on the results of the experiment, there's a percent error for specific heat of copper. Okay, so what does it mean for the percent error? It's going to be the change from the average experimental to the accepted. Is calculated best using which of the following expressions. So this is a little bit of a math concept. So the accepted is going to be the total, which is going to be on the bottom. So the answer has to be choice F. Now you can play with some numbers, if you wanted to actually incorporate each of these, calculate each of these in. But what ACT is really wanting you to do is understand the concept, not do the math. So you might take simpler numbers. Let's say you had 1/5, right? 1 minus 5 to be divided by 5 times 100. You have a 20% error. So you might play with some numbers, but it's really just the concept. Number 33, based on the experimental procedure. So we're using the numbered list. In each trial, a total of approximately how many temperature values were recorded? So I struggled with this one for a minute because I was trying to do each metal, but that's not what it asked. It asked for each trial. So just one time a metal is tested, how many temperatures were recorded, temperature values were recorded. So we first see it recorded at the temperature in step 3, and it says the temperature is recorded every 0.5 seconds, so every half second, and they recorded for 100 seconds, so that means it recorded the temperature 200 times. We see it again though in step 4, again it's recording 0.5 seconds for 120 seconds, so 240 seconds. So we add those two values together, 200 plus 240, and we get 440, and the answer is D. So here are the recording categories for this passage. So again, you can look and see if there's particular types of questions that give you difficulty. Reach out if you have any questions. Our silly joke, what's the best way to estimate the temperature on a mountain? Climb it. Have a good day.